Assuming you have already drawn your fishbone diagram in the previous activity, we are ready to go. In this lecture, we will apply each of the 4 stages of the fish methodology. To start, we need to find or identify a symptom or issue you want to analyze. As a reminder, this is our effect. In our example, we were walking at the Gemba one day and noticed a part that was produced to the wrong size. Seeing as we want to solve problems, this is the one we will look at. It's that simple. First, we enter the issue we found in our fishbone diagram head. Since we are using the functional 6M fishbone, we will not need to brainstorm the different categories. If you choose to do the brainstorming for your fishbone categories, be sure to update them. Next, we ask, why is this part produced to the wrong size? The team starts brainstorming and sharing thoughts. Our team comes up with quite a few ideas about how the part may have been produced to the wrong size. Here are some of the different sub-causes that the team comes up with. The shop was too hot. Material was old. The mold size was not correct. There was a mistake in the blueprint's measurements. The machine settings were not set correctly. These are all great ideas, so they should be placed under the correct category as sub-causes. You may notice that none of these are solutions. Remember, sub-causes are not solutions, although some of the ideas that you or your team will come up with may be possible solutions. Put them in your parking lot and be sure to investigate and do your due diligence with regards to the issue that you are trying to solve. Now we are ready to move on to our final step, where we will answer the question, how deep can we go? In our example, we will look at one of our sub-causes. The mold size was not correct. In your capstone project, you should dig in on all of your sub-causes. Let's start digging. Using the 5 whys, we will first ask, why was the mold size not correct? One possible answer might be, the machine kept stopping, throwing the setup off. In our next why, we ask, why did the machine keep stopping? One possible answer might be, the automatic shutoff kept engaging. After this possible level of causation is documented, we ask again. In this case, we ask, why did the automatic shutoff keep engaging? Again, a possible answer, the machine was overheating. Why was the machine overheating? It had run out of coolant. Why did the machine run out of coolant? The seals were damaged on the machine. As you can see, the 5th why took us in a completely different direction than the first why. Here's another tip. Different levels of causation may be different amongst different people. This is completely normal. The critical part is that the level of causation is something that you can control or affect. If you cannot, you need to back up and change the context of your why question. There will also be times that you can drill deeper than just 5 whys. This does not mean you have done something wrong. It just means you might have taken a different approach to your questioning and you need to keep digging. You should conduct a 5 why analysis for all of your sub-causes. Each of them may be a systematic part of the parts being produced to the wrong size. In our example above, if we were to continue digging, it may look something like, why were the seals damaged on the machine? When it's cold in the shop, we place a heater behind the machine that blows on us and it dries the seals out. The response to this digging produces something that we can control. You are probably thinking of a million different solutions for this problem, and that is great. Any one of them might work. However, we won't be going into the formation of solutions in this course, and we don't want to leave you hanging either. After you reach a root cause that is still controllable and your team has consensus that they would like to try and solve the root cause you discovered, ask yourself a how question or a what if question. For example, What if we placed a heater above the shop floor for the employees? Would that solve the problem? What if we moved the machine? Would that solve the problem? Try to remember there is almost always more than one solution for a problem. Now that you are familiar with the 4 steps of the fish methodology and we have applied the steps to our example, you're ready to go and complete your capstone project. We'll see you in the next lecture.